All right, so we've already gone through how to solve exponential and log equations in the previous few videos, but in this video, I'm just going to work through a few more examples. So if you want to see more of these worked out, then this might help you. Okay, so let's start with some more exponential equations. We're going to solve each equation. Okay, so let's say we have 9 to the power of 2x is equal to 1 over the fifth root of 3. So looking at this equation, I can see that we have a base of 3 on the right-hand side and a base of 9 on the left-hand side. Now currently we don't have the same base on both sides, but we could rewrite both sides as a power of 3. So on the left, I'm going to go ahead and change my 9 to a 3 squared. All right, now on the right, keep in mind that a fifth root can be rewritten as the exponent of 1/5. All right, now we can simplify both of these sides a little bit further. Left-hand side, remember that when you have an exponent raised to another exponent, you multiply them together. So 2 times 2x would give us 3 to the power of 4x. And then on the right-hand side, because that 3 to the 1/5 is in the denominator, we could change it to a negative exponent and move it up to the numerator. All right, well now we have the same base on both sides, so we can drop the bases and set the exponents equal, and then solve for x. So if we divide by 4 on both sides, think of that as dividing by 4 over 1, so it's the same as multiplying by 1/4, which means we have x is equal to negative 1 over 20 as our answer. All right, let's do some more exponential equations. Let's say we have 10 to the power of x plus 3 is equal to 835. All right, now this one, we want to start by isolating our exponential term. So I'm going to go ahead and subtract a 3 from both sides. So that would give me 10 to the power of x is equal to 832. Okay, now this time, we're not going to be able to use the one-to-one property like we did up here. Okay, that's what we did here, is we used that one-to-one property. Because unlike the previous example, we're not going to be able to write both sides as a power of the same base. 832 is not a power of 10. There's no way that we can rewrite it to make that work. So instead, we want to use the definition of a log to switch this into our equivalent log form. So we would change this to the log base 10 of 832 is equal to x. And remember, a log base 10, you don't really have to write the base, so that's just the same as saying log of 832. So that would be our exact answer. And then if you plug it into your calculator, you would get approximately 2.920. All right, let's try 3 times e to the power of x plus 1 is equal to 7. So again, we want to start by isolating our exponential term. So isolate the e to the x, which means we would subtract a 1 from both sides. That would give us 3 times e to the x is equal to 6. Divide by 3 on both sides, which would give us e to the power of x is equal to 2. And then we're not able to rewrite both sides as a power of the same base, which means we want to use the definition and switch this into log form. Remember, the log with a base of e is the natural log. So this becomes the natural log of 2 is equal to x. All right, so that's our exact answer. And then if we plug that into the calculator, we get approximately 0.693 as our decimal approximation. All right, let's do one more exponential equation. Let's do 4 plus 3 times the quantity 2 to the power of 3x minus 4 is equal to 13. All right, once again, we want to start by isolating the exponential term. So I'm going to subtract 4 from both sides. So 3 times our exponential would be equal to 9. Divide by 3 on both sides. So 2 to the power of 3x minus 4 is equal to 3. All right, now we're not going to be able to rewrite both sides as the same base. Again, we have base 2 on the left, base 3 on the right. There's no way we can make those the same. So we're just going to switch this into log form using the definition. All right, so that's going to become the log base 2 of 3 is equal to 3x minus 4. And then isolate x, so add 4 to both sides. So log base 2 of 3 plus 4 is equal to 3x. And then divide by 3, which would give us x is equal to the log base 2 of 3 plus 4 all over 3. All right, so that's our exact answer. And then if you want a decimal approximation, you're going to want to use your change of base property. So this would become the log of 3 divided by the log of 2 plus 4 all over 3. And if you plug that in, that's approximately 1.862. All right. Now, I do actually want to do one more exponential equation. This isn't something that you're going to see on the test, but you might come across it in the homeworks or the labs. So I just want to go ahead and show you this last exponential equation. All right, so this one's a little bit different because we have an exponential piece on both sides, but we don't have the same base. So 2 to the power of x plus 2, 3 to the power of x minus 1. So because we don't have the same base and we can't get the same base, we're going to switch this into log form using the definition. I'm going to change this to the log base 2 of 3 to the power of x minus 1 is equal to x plus 2. Okay, so switch that into our equivalent log form. From here, now that we have this in a log, we can use log properties. So this exponent, we can use our power rule to bring that exponent out front. And this would become x minus 1 times the log base 2 of 3 is equal to x plus 2. All right, now our goal here is to solve for x, right? And we have an x on both sides of our equation. Now, in order to solve it, we're going to have to distribute over here. So I need to distribute this, which would give me x times the log base 2 of 3 minus 1 times the log base 2 of 3 is equal to x plus 2. All right, so now we want to group our log or our x terms together. We want to get all of our x's on one side and get everything else on the other side. So I'm going to subtract an x from both sides, and I'm going to add a log base 2 of 3 to both sides. All right, so that's going to get us x times the log base 2 of 3 minus x is equal to 2 plus the log base 2 of 3. All right, now if we're trying to solve for x, both of these terms on the left now have an x on them. So I'm going to consider that x my greatest common factor and pull it out, which would leave me with a log base 2 of 3 minus 1. And then lastly, if we want to solve for x, we need to divide. So divide by log base 2 of 3 minus 1 on both sides. So that is going to be our exact answer. 2 plus the log base 2 of 3 divided by the log base 2 of 3 minus 1. All right, so that's our exact answer. And again, if we want to get a decimal approximation, we would use our change of base property. So this would be 2 plus, this would become the log of 3 over the log of 2. And then on the bottom, log of 3 over log of 2 minus 1. Definitely want to do this in steps or be very careful with your parentheses. But if you plug that in, you'll get approximately 6.129. All right, so that's all of the extra exponential equations that I didn't go through in the first set of videos.